Today, we're done with the theory. We're jumping straight into the terminal and breaking down the very first critical steps of a web app pen test, how to get that initial access.
Okay, so here's our game plan. First, we're going to uncover some hidden paths, see what the server is trying to hide from us. Then, we'll do some intel gathering to figure out exactly what we're dealing with. After that, it's all about finding a vulnerability and turning it into an exploit. The goal? To land our very first shell on the machine. And finally, we'll talk about what comes next, that next crucial step.
All right, let's kick things off. First up, uncovering hidden paths. This is where the journey really starts, with enumeration. You can think of it as, the art of carefully mapping out your entire attack surface before you even think about launching an attack. Look, before you can even think about attacking, you gotta know what's there, right? Web enumeration is kind of like an architect drawing up a detailed blueprint of a building before a heist. You're looking for all the doors, all the windows, maybe even some forgotten service entrances. This step is absolutely critical because sometimes a single hidden file or a forgotten directory could be your only way in.
So one of our go-to tools for this is GoBuster. Let's just take a quick look at the command here. We're using the dir module for directory brute forcing. We pointed at our target with the U flag, and then we feed it a massive word list with W. What it does is just relentlessly fire off requests checking for stuff like an admin login page or maybe a backups directory, or hey, maybe a config.php.back file that a developer accidentally left behind. This is exactly how we find the stuff that was never meant for public eyes.
Okay, now this is where having that pen tester mindset really pays off. Interpreting the results. A 200 OK? That's a direct hit, obviously. The resource is right there. A 301 redirect is also a fantastic clue, something we definitely need to follow. But check this out, the 403 forbidden. A normal user hits that and thinks, dead end. But for us, that's a win. It tells us that something exists there, even if we can't access it yet. It confirms another piece of our map, and that information is pure gold.
All right, so now we've got a basic map of the site from our enumeration. It's time to start digging a little deeper. We need to gather some real intelligence on the specific technologies this server is running.
Even a simple curl command can tell you a ton. When we look at the HTTP headers the server sends back, we can often instantly spot the server software. Is it Apache, Nginx? And here's the kicker. We can often see the exact version number. So why does that matter? Well, because specific versions have specific, well-known vulnerabilities. This header info can give us a direct target to start researching. Want an even more detailed fingerprint? For that, we can use a tool called WhatWeb. This thing goes way beyond just the server software. It tries to identify the underlying OS, maybe a content management system like WordPress, and even the programming frameworks in use, like PHP. Every single piece of this info helps us narrow our focus and really start to pinpoint those potential weaknesses. It's funny? Sometimes the server itself just hands you a roadmap. I'm talking about the robots.txt file. Now, this file is designed to tell search engine crawlers where not to look. But for a pen tester, that's just a list of the most interesting places to check out first. It's basically a treasure map pointing you straight to potentially sensitive spots, like a /private directory or an admin panel. And listen, never ever forget the basics. Just view the page's source code. Hit Ctrl+U in your browser. You would be absolutely shocked at how often developers leave little breadcrumbs for us, revealing comments, internal notes, maybe an API key, or, and this really happens, test credentials just sitting right there in the HTML. It's a classic mistake, and for us, it's a super easy win. Okay, so here's the crucial part. Once we've identified a specific piece of software and we know its version, we can start actively hunting for its known weaknesses. This is the moment. Right here, where all of our patient reconnaissance starts to pay off. We're shifting gears now, moving from just gathering information to active exploitation. All that data we just collected, it's about to become actionable intelligence. A great first step is to just check for publicly available exploits, and a command line tool like Searchsploit is perfect for this. It lets us query the massive exploit.db database right from our terminal. We just feed it the software and version we found, like OpenSSH 7.2, and boom, it'll list any known public exploits we can potentially use. Now, for a more powerful, all-in-one approach, we're going to turn to the Metasploit framework. This thing is a massive collection of prepackaged exploits. It basically streamlines the entire process into this simple 4-step workflow. First, you search for the right exploit module. You load it up, you set your options, that's the target IP and your own listening IP, and then you just type exploit.
Metasploit handles all the messy, complex networking and shellcode delivery for you. It's an incredible tool.
And a successful exploit that gives us our primary objective for this whole phase, a remote shell. Now, we're not just viewing a web page anymore. This is an interactive command line on the target machine. This is our first real foothold inside their network.
So there are really two main types of shells. You've got a bind shell, which opens a port on the target, and we connect to it. But the one you'll use most often is a reverse shell. This is where the target machine actually initiates a connection back to us. And why is that so great? Because it's incredibly effective at getting around firewalls that are set up to block incoming connections.
So to catch a reverse shell, the first step happens right on our own attack machine. We use a simple but super powerful tool called netcat, or NC. The flags here, LVNP, just tell it to listen, be verbose, use numeric IPs, and do it on a specific port, in this case, 1234. We're essentially just setting up a trap, sitting there, waiting for that incoming connection from our target.
Next, we use that vulnerability we found to trick the target into executing our payload. And this one-liner you're seeing, it's a classic reverse shell. Let's just quickly break it down. It's telling the target's bash shell to open a TCP connection back to our IP address on port 1234. And then, this is the magic part, and greater than redirects all the output and errors into that connection, and 0 greater than 1 redirects the input too. So in short, everything we type goes to their shell, and everything their shell outputs comes right back to us.
And this is the payoff. Our listener catches that incoming connection, and just like that, our local terminal prompt is gone. It's replaced by a prompt from the remote machine. We can run a command like ID to see who we are in that system. We have a shell. We are in.
Now, getting a shell is a huge victory, don't get me wrong, but the work is not over, not by a long shot. Our initial access is almost always as a low-privilege user, like the www.data user that just runs the web server. We have a foothold, yeah, but we don't own the machine. Yet.
So the question becomes, you've got a shell, but you're not the admin. How do you become the true master of the machine? Well, the next phase is called privilege escalation. It's all about finding a new vulnerability, this time inside the machine, to elevate our permissions all the way to the top, to root on Linux or system on Windows. But that's a whole other story and one we'll dive into in our next explainer.